In the last lecture, Dr. Sarkar talked about client-server systems and which relied on the concept of sockets. And thus, one type of the basic communication mechanism in the server and client, as was discussed, was based on the concept of socket in the way that a server has a socket open and which is bound to the appropriate address in the server, and the server listens to the socket and it will accept a connection from a client which is also has a socket and connects to appropriate for establish and has a connect construct which just helps it establishing connection with the server socket. Now till the communication is established between the client and the server will wait until the connection from the client is established, in the sense that it will listen to the socket to see whether there exists a connection request from its client. And once it is established, it will try to receive the data which is being sent by the client and the process the same, and here it will, at this stage, it will process it and sends the result data to the client. This is what was the typical client's connection oriented protocol, which was discussed in the last two lectures. There exists also the type of communication in which is called connectionless protocol, which was also discussed in the manner that, again with the help of sockets concept, in which the client will send the data to the server through the socket, and until and unless this data is received, the server will wait, and after that it will process it and send the result from the server to the client. So the server sends the reply to the client, and when it gets a request, it processes it. Now, for implementation of this kind of communication mechanism, we will look into the Java language, as we had discussed earlier. And in fact, in Java, the concept of socket is very much intimately is very much there, in the sense that Java supports a class called the socket class, and it is defined in java.net package. So what we have just seen or discussed earlier, socket is treated as an inter-process communication channel. Once connected, processes can read and write through such communication channel. That's the basic concept of socket. And the class sockets with its methods are defined in the Java.net package. Java also supports a type of socket which is called a TCP/IP socket, which is useful in internet programming, communication through the internet, and it is also this type of sockets has a port number associated with it, and it is used to implement point-to-point stream-based connections between programs that may reside on the local machine or on the internet. So the two machines that will be communicating, the server and the client, they may be distributed over the internet and communicate with each other using the type of protocol just mentioned. So therefore, in a connection-oriented protocol, the server will listen to the socket till a client connect call is made by the client, and once the connection is established, it will receive the data and request. Now, before we go into the implementation of the client-server system in Java, using Java, we need to look at a new concept called the threads. And why that thread, we'll just briefly see here. For instance, that suppose at this point, when the server has received the data request from the client, and then it has to process this request. Often such a request may require quite a bit of time of processing. Like, for example, the server is a database server and client wants to access particular some record from this database based on certain conditions. And that will involve a lot of search on the database, and until when the appropriate data is received, then and then only result can be sent by the server to the client. Now, in between, it may be the case that another client wants to communicate or wants to receive the data from the same server. So, in that case, the server cannot process it because he is busy. If it is done in this manner, simple, straightforward, sequential way, it cannot process it until it completes the request from the server, say client number 1. Now, in order to solve this problem, most of the servers, what they do, they fork out another process, child process, and once the connection is established, and then through the child process, it will try to process the client's request, and then listen back to the socket again to see whether the another client wants to communicate with it. And that's way the same database server can be able to communicate with the multiple users who are the clients which want to communicate with it. Now, the idea of the process, so therefore we are back to the concept of what is a process, and then the concept of the thread. The idea of the process in an operating system environment is fairly well known, and it must have been covered in OS courses. And to give a very brief idea of what the process is, if you look at it, in fact, the server program by itself can be thought of a process. Similarly, client program also can be thought of a process. So, in a multi-programming environment or in a distributed environment, there are multiple processes which are communicating through the communication media, which may be local or may be in the distant in a distant machine over the internet. And now basically the idea of the process is, therefore, a process is a collection of, as we come to the concept of thread, or in fact it is one or more programs, you can say, and associated system resources. A process, whenever in an operating system environment is executed, it will be allocated a virtual address space and control of other resources like I/O devices, etc. If you recall your courses on operating systems, we can see that a process normally can be in different states, such as when a new process is created, we have a fresh process is created, and it is placed in the ready queue in the sense that now it is ready for execution, and the process scheduler will take the job from the ready queue and will select it for execution, that is dispatch, and it will be running. Now, sometimes the process, when it tries to do some I/O processing, since it takes quite a bit of time, it is blocked in the sense that this I/O drivers are programs are scheduled, are executed, and the data is transferred from the I/O devices to the system. Until then, the process may be blocked, or the process itself may be blocked because it is expecting certain input from the external world, and so it cannot be running. Again, in time sharing environment, the processes are given some time slice, and once the time slice of the job is over, it is placed in the ready queue again and is not running, and another process is given the option of running into the CPU. And once the process execution is over, it is released. Now, if you look at this model of the process now, as a simple model of the process, and then we see, therefore, that a process, when it's executed, for executing a process, lot of information has to be stored into the memory before it can be executed. And typically, a process image will have following informations, which we call the user data, in which will contain the data required for execution of the program and some user stacks. Then the program area, that is a code, the program code that is being executed. Then there are some system stacks which are used for implementation of the procedure calls. And then each process will have its process control block, which includes the process identification. Then we have some CPU registers. What is the current status of the CPU registers? what are the stack pointers, and similarly what is the type of scheduling it is being followed, and what is the status of the scheduling, then state information of the process, where we have already seen whether the process is ready or active, that is running or blocked. Then what is the IO status of the information, meaning whether it is going to be, whether it is waiting for the response from an IO device, or it has initiated some IO device and IO routine on which is not yet responded yet. Then the memory management information is that in which area of the memory this process has been loaded, or it is whether how many pages it will be allocated till now. So there are different memory management schemes, and the information relevant to this particular process will have to be maintained. Resource utilization and inter-process communication, meaning then what are the resources the process has acquired, what is the status of those resources, whether it is locked certain tables, and inter-process communication, what are the processes with which it is communicated. In a typical Unix environment, a user process looks like this. We have this code area in which the text and basically essentially the code area for the process program. Then some initialized read-only data which cannot be modified, and these are the area which it can modify it. Similarly, this is the stack and the heap area, where the heap is essentially when a program requires large amount of additional memory, it is allocated from the heap. Now, if you look therefore, and the example we had been talking, that when a process is, server as a process is blocked, it is processing a particular request from a client. Now, if I want to perform this one into another process by forking, say, then in order to create such a process, this kind of information has to be loaded into the memory, and the context switching has to take place. Normally, this thing takes quite a bit of time, and may not be often necessary in some simple applications. So essentially, looking at a process, therefore, that we can implement client-server system using multiple processes, where we have a parent process and then there are children processes which are essentially in the server, which are serving different requests from the clients. As opposed to the concept of the process, or in fact derived rather from it, is the concept of thread. This is we can think thread as basically a simple sequential flow of control which is also interruptible. So let's look at the thread. What is a thread? Thread is a dispatchable code having sequential flow of control. And example is, say, suppose in a text editor, we are doing a text editor, whichever some word processor is there. You are formatting the text, so you are changing some of the content of the lines, and simultaneously you want to perform printing also, and these can be done in different threads. And or you can save the format, whatever data you have formatted, into the disk, so that if there is a failure or some arbitrary part failure or other thing, that whatever you have changed or so far remains permanently stored. So in that environment, one way of doing it is that we can fork two processes, in which one process we can do the basic word processor process, we can do the formatting here, and in another process we can do the store. Now this idea, therefore, if we treat them as the two separate processes, we will have to make context switching from one process to the other and load the corresponding process information into the memory. Instead of doing it, we can look at this one as a very simple job, because after all, both of them are sharing the same area of the memory, and therefore instead of allocating a different memory space, we can run on the same memory area, and we have then what we call the concept of thread. So therefore, we can think it of as we look at the definition of a process. A process can be thought of collection of one or more threads which can be run concurrently. That is what the most important thing. And these threads are sometimes called the lightweight processor. They have a behavior somewhat, as we'll see later, somewhat similar to the process, but thread is called the smallest unit of dispatchable code. That so when you want to remove, you can, this is smallest amount you can move from one place to the other. And the major important thing is that threads of a process share the memory and resources of the process with each other. So if a process can have multiple threads which can run concurrently and they share the same area which we have just now mentioned, that when a process is loaded, some information is stored into the process image, that area is allocated to it. Now they can share the same area while during its execution. Like in Unix processes, the area allocated for a process, we can allow the multiple threads to work in the same use the same area among themselves and communicate with each other. So threads can communicate with each other, they can share the same area, and this is the smallest unit of code which we can move in or out. So by this process, what the idea, this concept, what we are doing, essentially we are breaking a big process into several threads which are somewhat inside it, and then operate in the manner so that the threads are somewhat running concurrently. Like in the example we had seen just now, we can execute this word processor, word processing as a process or a text editor, and it has separate threads called formatting, store. These are executed in a different threads. So this is what is the difference between the process and a thread. And so now let's look at some of the usage of the threads. And before one example is that there are usages like this, that for asynchronous processing, the storage of files just now mentioned, while they are being edited by a word processor in a disk at regular intervals. So every time when you are doing the editing in a background, you can run a thread. That thread will go on storing whatever we have modified till now into the disk. Displaying menus and reading user input in one thread and executive commands in another thread of a spreadsheet program. So you can use these while implementing spreadsheets. We can have multiple threads to do different tasks in concurrently running threads. Client-server computation, as just now I mentioned, the client-server computation, we had seen that it requires clients and the servers to do different tasks, maybe different tasks. We can do whatever the processing that is being asked for in different threads. Just say sometimes you may ask a retrieval of a data, sometimes we may ask some modifications of the data, which we can, or displaying the data into a typical format. So those can be done different threads of the server program. So there is a server process which has multiple threads in it, and these threads are supposed to do different tasks. And meanwhile, one thread in one main server process goes on listening to the socket, and once it receives an information from a client about a connection, it spawns a thread, and that thread then goes on executing, doing the jobs. Then we have, as I said, handling multiple and input-output requirements of a program. So if, for example, in one thread we can take the input from a mouse, another thread can be used to take the input from the keyboards, and so on. So the idea of, therefore, this is main distinction between the concept of a thread and a process. And so threads, as I am repeat, is essentially a simpler unit. It's also a code, and it is much simpler than the processes. And a process we will think of is as one or more threads, a collection of one or more threads. So in a process we can have several threads. Some of the threads will allow them to run concurrently. That means they can, provided they are using some different resources. like in the example, suppose in a program in a program we want to get the input from the keyboard as well as from the mouse. Now these two can be definitely run in the different threads because they are not conflicting in each other, and so these processes, these threads, one thread can execute, take the input, deal with the mouse, another for the printer. Similarly, another thread can be used to design what is to be displayed in the monitor. And now, so basically this idea of the thread is now being used in different in operating systems environment also, and there are quite a few operating systems which rely on the concept of threads, and some of the examples are the classic the Windows NT, which is essentially uses multiple threads, concurrently running threads to implement the operating system. OS 2 also supports thread. Solaris is a version of Unix by Sun, and that also supports the concept of thread. So therefore, what why we change from our basic concept of client server computing model that we had been discussing so far is that what we will like to see that first of all how when we try to model server and the clients, we will use thread concept to allow server to communicate with the multiple clients, to listen to multiple clients and do the processing for the specific client once a client is established, a connection is established into different threads. So that will be our idea when we look at the implementation of a client server system in Java. So once we now therefore establish the definition of a thread, let's now look at how Java, because if you want to show that this thing works that can be implemented with the help of sockets in Java, we will need the help of the threads, the idea of threads, and in this respect Java language supports threads as a class, and there are lots of methods along with the thread class which help in implementing the concurrently running threads and synchronizing them. So coming back therefore to Java again, so basically in Java threads are treated, any thread is treated as an instance of a class, thread class. If you recall our definition recall our introduction to the Java language, Java being an object-oriented language, it heavily relies on the concept of class, and in each class there are certain methods. And a typical instant thread is treated as an instance of the class, thread class, which is a built-in class which is applied with the Java language. Then in this, for the creation of a thread, therefore, the Java supports a constructor, thread constructor with the thread class, and we can say thread, my thread is a new thread. So I am creating an instance called my thread, which is for using the constructor thread. Now let us look at the life cycle of a thread. If you compare it with the life cycles or the states of a process we had seen earlier, that a process when it is in its execution state, there can be different stages. It can be when you are creating, then you are starting, and then this part is that you are putting in a queue and then it is running. Actually this is an active. In these two states the process is really in a suspended state. Here it is blocked due to resources. Here it is waiting, because if you are want to run the process in a single processor environment, naturally if you have 10 such processes to run on a single, you cannot do that. So one of them will be given option of running. So it's waiting in a queue to be given the CPU resource. So essentially this is also in a waiting state, but the states are defined in a slightly refined in the way the suspended stage. One is blocked, another is ready, and then it's running and then halted. If you look back to the concept, this life cycle of a thread, it is very much similar. Here the suspended state we can combine the two in the ready and the blocked. So we have a new thread which will start, then this will be running, When you start a thread, it will be running, and then when the thread is waiting for some input or output to occur, or it may wait for certain connections to be established with the, for interprocess communication, then it will be suspended, and then once the thread execution is over, it will be terminated. So therefore, there is a one-to-one almost correspondence. If we just further decompose this one into two more, like ready and block, while we the states of a process. So the life cycle of a thread consists of the four life cycle new Java threads are new thread, it's a running thread, it's a suspended thread, and a terminated thread. So then therefore, when we create a thread, essentially we use the creation of the thread using the new construct, we are creating a thread here. The next step, it must start. The thread must start its execution. And for doing that, we look at how to start a thread in Java. So therefore, after a thread is created, it can be started by executing its run method. So every thread in a thread class, we have a run method, and the run method of a thread class does nothing. It is, however, in the basic thread class that we have defined, that is the parent class in the Java thread java.net package, that thread class actually does not do nothing. And so what will be necessary that you can, as we have discussed earlier, there are two ways to define a concrete code for running a thread, and that can be done by either by taking by defining a subclass of the thread class, or that which extends where you extend the run method, or by implementing the runnable. These two we have discussed when we have been talking about how to have a concrete instances, concrete methods of abstracts when you have an abstract class like a method like this. So therefore, what are the two ways? To start a thread, Java supports two approaches: create a subclass of thread and define a new run method that performs the necessary task. So even a particular type of thread, you want to do something specific, so write the run method accordingly. Alternately, create a class that implements runnable interface in thread class, and this class must implement the method run. We'll see both the approaches in our subsequent discussion. So what we have therefore seen, that Java is giving you the very basic feature of defining a threads in its thread class, creating new instances. You have is giving you the option of defining the run method, where you can write your own code using Java language to start the thread. And once you have started the thread, then it will go. It can be suspended depending upon what it is trying to do, whether it's trying to do some I/O or rather waiting for some information. And when does the thread execution terminates? It will be that when its run methods is over, execution is over. So let's try to see that out of the two approaches for implementing the thread run method, let us take the first one, in which we create a subclass of thread and define a new run method in it. For instance, let's say overriding run in a subclass of thread. Typically, we have defined a my thread class. This is a new class I am defining, extends thread, and in which, if you remember the super concept, that means it will execute the constructor of its parent class, which is a thread, and then just print something and start the new thread. Here for execution, it will run the run method, which we are now giving a concrete shape. And here we are saying that, say, system.println just prints the value of j, and then the thread sleep. So thread sleep means thread goes on waiting. It's a very simple example, and it sleeps for 2000 units, which is in milliseconds, and then and goes on doing it for 15 till this loop. So therefore it will go into, it will first print this line, then goes to sleep, and after that when it wakes up it will again go on doing this. So and it is also can catch, if you remember we talked about exception clauses. If there is such an exception arises, that is it is being interrupted, say catch interrupted e, and then it will print that my thread is interrupted. So whenever this thread gets an interrupted machine exception because some other threads may be executing, then it will then it will print this message like this. And when the thread has terminated, that is, as we have just mentioned, that there are one state in which thread gets terminated, and here it reaches this state when it comes to the end of the run method. So therefore here we have it goes on running, and when the end of the run, the thread is terminated. And in this state, when the thread sleeps, this is when this method is executed, thread will be in a suspended state. So this thread is no longer running, it's waiting, it is going into the sleep, and whenever that the interruption, when the sleep time is over, it will catch the exceptions and it will start again until this loop is over. So whenever this exceptions will place any other thread is trying to interrupt it, it will print that it has been interrupted. This is one way of doing it. Like you have a simple method in which we are having two threads. This is the first thread and this is a second thread. It will go on executing the first thread. It will print the first thread here. It will start the first, my thread is, so this will be printing the first thread, and then goes on implementing waiting for 2000 milliseconds, and then slowly about 15 times, and similarly the new method my thread class second thread also will be running there. Now this is how we can start multiple threads, how we can make some threads to wait for some time, how we can make the threads to come execution to be terminated. An alternative way of implementing the thread class run method is by using the concept which we are using the runnable. Unlike here we had tried to do is that use the my thread class is a subclass of thread. Instead of doing it, we are saying that it implements, this is an independent class which implements the runnable interface, and here again we are using the same idea, that is we are create a thread and then t dot start. So this new thread will be started, and here this thread also we are asking it to sleep for 22,000 milliseconds, and then on the then when it reaches this state, after that finished execution, it is printing my thread is terminated. So what we have observed therefore, that the threads as an object is typically an instance of a thread class, and we can create the instances of the runnable interface or the run method by the two approaches, one defining a run method in a subclass, and or with the help of runnable interface like in this example. In our later on when we look at the client server implementation using Java, we'll see that we'll use either of these two approaches in implementing our the client and server communications. Lastly, with connection with the threads at the moment, so let's look at how do you suspend and resume thread execution. So a thread which is not runnable will be, that means you can push a thread into a suspended state by either by the help of the method execution like sleep, or with the help of some specific calls. So using suspend calls, that is a thread, you can deliberately ask a thread to be suspended, and a thread suspended can be resumed by the resume call. These methods are defined in the thread class, and these are that is the final void resume and final void suspend. Whenever a thread you want to suspend, we can write that you just suspend this thread, let it wait, and whenever then later on we can resume this thread. Another way of putting the thread into a suspended state is that thread executes a wait method in which it waits for a specific condition to hold. Now this you will see an example in our later on, that wait methods can be called inside a synchronized method, with the idea we will come to next lecture, is that what is synchronized method. And then when a thread is waiting on a condition, another thread must notify it that the condition has changed using the construct called notify all. So basically what we are saying, say we have, suppose this is one thread is executing and this is another thread. Now this thread, say thread 1, waits for something at this stage, at this of its execution, and here it's wait, and at this stage when this thread has finished or has done something, it makes a executes a method, say notify all, that the condition on which wait on certain conditions, say C condition, the condition has been satisfied, when this condition is met, so initially this condition may not be true, so that is waiting to this to be true, say thread T1, and when the execution of this thread, this thread then informs it that the condition has been satisfied, and so then it will resume its execution from this point onwards. So it was waiting, coming here and executing up to this point, and at this point it executes a waits there, and here also this another thread which was going on executing, and it finds that the condition that this thread was waiting has been satisfied, so it informs everybody that well, the condition is met, so this thread can then start its execution. So therefore we have now two threads which were executing concurrently, and certain point you have make this thread T1 to stop, and this one, when it is executing at this point, it informs that well, you can now proceed using notify. We'll see the usage of the notify. This is basically the way how the two threads execution can communicate with each other, and show that and how it will be possible to synchronize them. But till then, till this thread receives a notify message from the T2, T1 will wait, and it will be in a suspended state. So therefore thread executes a wait method and waits for a specific condition to hold, and wait methods will be called, this will come to the concept of synchronized method in next class, and when that condition is met, the other thread will inform it that it can proceed. So what we have now therefore seen, that it is possible to start a thread, it is possible to run the thread using appropriately encoding its run method by specialization of it in its subclass or with the help of a runnable interface. It is possible to make the thread to wait or a block state using suspend method, or with the help of sleep type of methods, or with the help of wait calls. And then once this thread suspension period is over, it can be resumed in its execution, and then when the run is over, it will be terminated. So that is basically how the different states of the thread or the life cycles of a thread can be implemented with the help of Java, and for that Java supports several methods in its class library. So what we have now therefore seen today in this lecture is that it is that what is basically the different, what is a thread and how does it differ very brief with the concept of process, and later on what we'll like to see that how this concept of thread can be utilized in implementation of the client-server communication. But before that, we need to little bit to go into the depth of the thread, in the sense that that we have just now mentioned that the threads can communicate with, that is the what are the different modes of communication of a set. This is one thread, say T1, and that is another thread T2. How they communicate with each other. So this is a code, this is going on executing concurrently. This is another thread which is executing concurrently. How do they communicate? And secondly, the more important is that suppose there is an object X which both of them want to access and modify. So that in order to keep the consistency of the object, how do you synchronize their access? This is very important, and we will be discussing that in the next lecture.